In this video, we're going to look at some more examples of problems with using our exponent rules and negative exponents. I went over several examples in the previous video, but these get a little bit more complicated, and so I thought we would work some like this as well. Alright, so let's start with this one. X to the negative fourth, y to the third, over x to the negative fifth, y to the negative sixth. Okay, so we've got some things that can be simplified here using exponent rules. We've got negative exponents we need to get rid of. And so, as I've said before, there's usually more than one way to go about a problem like this. As long as we're using our rules correctly, it should not matter which way we do it. So let's look at a couple of different possibilities here. As I said before, some of you might see these negatives right off the bat and you might say, oh, I don't like these. I would like to get rid of those negatives first. Okay, so that would be an acceptable way to go. In doing that, we would need to move the x to the negative 4 to the bottom and the x to the negative 5 to the top. So when we bring this to the top, it'll be x to the 5th. The y to the 3rd is good up there. It's already got a positive exponent. The x to the negative 4 would need to come to the bottom and be x to the positive 4. And then this would need to move as well. The y to the negative 6 would move to the top and be y to the 6th. Well, now everything is positive, but we do have some simplifying that we can do using our exponent rules. We've got our x's that are being divided, and our division rule says to subtract your exponents. 5 minus 4 is 1. So that's going to leave just x to the first. That will be considered to be on the top. And then here, these are being multiplied, the y's, and so we'll add those exponents and get y to the 9th. So our final answer is x, y to the 9th. Now, if we wanted to, wanted to first do the division rule, we could do that as well. Okay, here's the same problem. These x's are being divided, and when we divide, we subtract our exponents. So for the x's, we would have negative 4 minus negative 5. Okay, and negative 4 minus negative 5, let me grab my highlighter, that becomes plus, and so we get just x to the first. And for the y's, it would be 3 minus negative 6. Well, 3 minus negative 6 becomes 3 plus 6, and that would be y to the 9th. So we could do it that way as well, which is the rule that says when you divide things that have the same base, you subtract your exponents. All right, so let's try another one. What if we have negative 4ab to the negative 2 raised to the negative 3rd power? Okay, again, multiple ways to do this. If you don't like this negative exponent that this whole thing is being raised to, then you can take the entire thing and move it to the bottom. Now, when we move it to the bottom, I want you to take note that nothing in those parentheses changes. None of these signs change. I know we're moving it to the bottom, but we're moving that whole thing to the bottom to change this exponent. This exponent that whole thing is being raised to, a negative 3, will now become a positive 3. But I do want you to make a note that nothing in the parentheses changed when we did that, okay? Only this exponent out here became positive. All right, now I'm going to take everything in those parentheses and raise it to the 3rd power. Negative 4 to the 3rd power is negative 4 times negative 4 times negative 4, which is negative 64. This a has an understood 1 on it, so we'll use our power to a power rule and multiply. 1 times 3 is 3. Power to a power here as well and multiply, and we'll get b to the negative 6. Now we're almost done, except now we've got another negative exponent we need to take care of. Okay, we can't leave a negative exponent in our answer, so I'm going to bump this b to the negative 6 up to the top and make it b to the positive 6. And then down here I'm going to have 64a cubed. Now that is a negative 64, but I don't like to have a negative on the bottom of my fraction, so I'm just going to bump my negative out here to the front and put 64a cubed. So this is a negative b to the 6th over 64a cubed. All right, let's try another one. I know that can be a little bit tricky. All right, negative 5, x to the negative 2, y to the third, all raised to the negative 2 power. So once again, if we want to fix this negative 2 power, we can take this entire thing, move it to the bottom, and change the power to a positive 2. But what you have to be super careful of, this is where people mess up, what's in this parentheses will not change. That's still a negative 5. This is still x to the negative 2, y to the third. Just now that whole thing's being raised to the positive 2 power. Okay, so if I raise everything in the parentheses to the positive 2, negative 5 squared is positive 25. Here, a power to a power, we multiply. So we get x to the negative 4th. Power to a power, we multiply. We get y to the 6th. We have one problem, that's this with the negative exponent. It's got to be moved to the top so that that exponent will become positive. All right, you can keep the 1 there if you want to, but once you move that x to the 4th up here, there's an understood 1 in front of it, so you don't have to write a 1. And you have that over 25 y to the 6th. Okay. I'm going to work several more of these because I know these are tricky, and I think the more we practice, the better you'll be. Okay, so this just looks like a multiplication problem. So we're going to follow our rules for multiplying. We multiply the coefficients in the front. We add exponents of anything that have the same base. So negative 8 times 2 is negative 16. We've got y's here. A negative 12 plus 16 is positive 4. Don't have anything to add to my z's, so I'm just going to put the z to the negative 2 there on the end. Now, please know we can't leave negative exponents in our answer. But please don't get confused, because I have students do this all the time. They think that this negative 16 is a problem. Y'all, it's fine to have a negative coefficient. That's not a big deal. What we cannot have is a negative exponent. So don't try to fix negative 16. It just is what it is. So we have negative 16 y to the 4th. All of that's good. This z to the negative 2, we've got to bump it to the bottom and make it z to the positive 2. And that will be our final answer. Okay, let's see. Let's do one more like that. 5p to the negative 2 q to the 5th times negative 2p to the negative 4 q to the negative 1. Once again, looks like just a multiplication problem. We're going to multiply our coefficients. 5 times negative 2 is negative 10. We're going to add our exponents for each individual variable. We've got p's. A negative 2 and a negative 4 gives you negative 6. A positive 5 and a negative 1 gives you positive 4. Okay, once again, a negative coefficient is not a problem. Leave negative 10 alone. He's good. Q to the 4th is fine. It's that p to the negative 6 that needs to move to the bottom and be p to the positive 6. Okay. Negative 8, a to the negative 6, b to the 4th, over 10, a to the negative 2, b to the negative 3. Yuck. All right, we've got a lot going on here, and that's okay. We're just going to follow our rules. Again, there's a lot of ways we can go about this. I think that I'm just going to use my subtraction rule. That says when we divide things with the same base, we'll subtract the exponents. Now, because we can't divide negative 8 by 10 and get like a nice whole number, we're just going to reduce this. Negative 8 and 10 are both divisible by 2. And so if we divide them both by 2, we'll have a negative 4 on the top and a 5 on the bottom. It's kind of like just like reducing a fraction right there. Okay. Now for my A's, I want you to think about what's going to happen here. For A, I'm just going to write it down here. I'm going to have negative 6 minus negative 2. So when we have minus a negative, that's going to become plus. So negative 6 plus 2 is negative 4 for my A's. Now, when we do this subtraction, the answer that we get will always go on top, and then if it has a negative exponent, we'll shuffle it around in a minute. But when we do this subtraction, this is going to be on the top. Okay, same for the B's. For my B's, I'm going to have 4 minus negative 3. Well, 4 minus negative 3, anytime we have minus negative, it becomes plus. That's going to be b to the 7th, and it goes on top. All right, now, everything is good except this a to the negative 4th. We cannot have a negative exponent in our answer. Negative 4 is fine. It's a coefficient. Don't bother it. That can stay on top. The b to the 7th can stay on top. We have a 5 down here. We're going to move the a to the 4th to the bottom. Okay. Last one. We're going to have 2p to the negative 4 q to the 3rd over 5p squared q, all raised to the negative 2. Okay. So, here you might see that there are p's and q's inside our parentheses. So this could technically be simplified first before we raise it to the negative 2, or we can go ahead and raise it to the negative 2 and then simplify. I think what I'm going to do is let's get this exponent positive first. And remember, when we have a fraction raised to a negative exponent, we can just flip the fraction over, and that'll make the exponent positive. Now, when we flip this fraction over, don't change any signs inside the parentheses. It's just like what we did over here, where we took this and raised it to the negative 2. See how nothing in the parentheses changed, nothing in the parentheses changed, just the sign of that exponent when we moved it. It's going to be the same thing here. I'm going to flip that over, not changing anything inside the parentheses except to flip it over, and that takes our exponent to a positive 2. Okay, now however you want to do this, if you want to do your division rule next, you can. If you want to raise everything to the second power, you can. I think I'm going to go ahead and raise everything to the second power. So I'm going to have 25 on the top. Power to a power, we multiply, so p to the 4th. Power to a power, we multiply, so q squared. On the bottom, 2 squared is 4. Power to a power, we multiply. Power to a power, we multiply. Okay. All of the same things have to get taken care of no matter what order you go in. So we're all going to have to do the same steps. It just depends what you want to do first. All right, so now I'm dividing, and I can subtract my exponents. Okay, so I know my 25 and 4. I can't divide it evenly, and it won't simplify as far as like reducing. So I'm just going to leave a 25 and a 4. For my p's, I'm going to have 4 minus negative 8. Well, 4 minus negative 8 will become 4 plus 8, and that will be 12. So I'm going to have p to the 12th. That'll go on top. Remember, it'll always go on top unless we need to shuffle it around later. And then the q will be 2 minus 6. Well, 2 minus 6 is negative 4, and that will go on top for now. So then we examine this answer, and we're almost there. The only problem we have is this q to the negative 4, and we can't have that in our answer. So I'm going to write my final answer right here in the corner. 25 p to the 12th over 4q to the 4th. That is my final answer. No negative exponents.